Today, we're going to look at a hidden connection in mathematics, a story about a pretty simple idea from high school that, it turns out, holds a really powerful secret.
So, what if I told you that a core math concept, one you probably spent a good bit of time on, was only ever half explained to you? Well, it seems for most of us, that's exactly what happened. You definitely remember these, right? Arithmetic progressions. Just a list of numbers where you add the same amount each time to get to the next one. Super simple, totally predictable. A classic of every math class.
And in school, what did we do with them? We got really, really good at one thing, adding them all up. We learned all the tricks to find the sum of all the terms. But that's only one side of the coin. Because what happens when you try to multiply all those terms together? It's weird, right? Most textbooks just kind of skip it. It's treated like this messy, complicated problem that doesn't have a nice, clean answer. The old way to do it is basically just brute force. You have to write out every single number in the sequence and then multiply them one by one by one. For a short list, it's boring. For a long one, it's an absolute nightmare, and you're almost guaranteed to make a mistake. Now, to get around that nightmare, mathematicians developed these separate, kind of clunky formulas for specific situations. Like, here's one for even numbers, here's another for odd numbers. But what if you could just toss all those out and replace them with one single, unified formula that just works for everything?
Well, that is exactly what a team of researchers have come up with. It's this elegant formula that does way more than just calculate an answer. It actually builds a bridge between the math you learn in high school and some pretty advanced university-level concepts. So the first piece of the puzzle is something you definitely already know. The factorial. Yep, good old factorials, a high school classic. It's our anchor, right here in familiar territory.
The second piece comes from the world of higher math, and it's called the gamma function. Now, I know that might sound a little intimidating, but just think of it like this. It's a super-powered version of the factorial. It's this natural next step that can handle a way bigger range of numbers, not just simple whole integers. And here is the absolute key, the insight that makes this whole thing so powerful. You don't need to be a math genius to use it. In this formula, the gamma function just acts like a simple algebraic tool. It's surprisingly easy to use.
Okay, so the theory is beautiful, but does it actually work in the real world? To find out, researchers in Mozambique ran an experiment with 29 university students who were all training to become math teachers themselves. First up, they gave the students a pretest using all those old manual methods. Out of a possible 20 points, the average score was a 9.22. I mean, it's a passing grade, but yeah, lots of room for error. Then, they taught the students the new unified formula and gave them a post-test. The new average score? 14.23. Wow, that is a 5-point leap in performance. And just look at the difference here. This wasn't just a tiny little bump. It was a huge, dramatic improvement. The new method was just way more effective and led to much better accuracy. And this wasn't a fluke either. The statistical analysis confirmed it. The improvement was significant. This formula had a direct, positive, and totally measurable impact on how well these students performed. Okay, so it helps students get better test scores. That's great. But why does one single math formula really matter in the grand scheme of things, especially for a developing country like Mozambique?
Because this kind of mathematical reasoning, it's absolutely essential for the country's future. We're talking about the foundation for economic management, like calculating interest for microfinance programs. It's critical for public health, for making projections about diseases, and it's vital for technology, for building more efficient computer algorithms. And this is what's so incredible about this whole approach. It's not just about finding a faster way to do a calculation. It's about taking a problem in education and turning it into an opportunity to innovate, a chance to teach better and to connect different levels of learning. At the end of the day, that is the real breakthrough here. This formula is a bridge. It connects what students are learning in high school with what they're going to need in their future careers, making math feel more intuitive, more powerful, and way more connected to the real world.
And that just leaves you with this fascinating thought, doesn't it? This was a huge gap, hiding in plain sight in one of the most basic topics in math. It really makes you wonder, how many other simple, powerful connections are just waiting out there to be discovered in the subjects we thought we already knew inside and out?